Alright, so today we're doing lesson 32 on polynomial functions. So to start with, a polynomial function of degree n in the variable x is defined by this, which looks ugly, but all it really says is a number times x to a power plus another number times x to a lower power plus another number times x to a lower power plus another number times x to a lower power until you run out of powers and you just have a constant. So things that we have to remember is that all of the a's are real. A sub n cannot be 0, and n must be a whole number. So basically it boils down to, this is the leading coefficient, provided you're in standard form. The first number is the leading coefficient. The dominating term is the first term, again, when you're in standard form, so the term with the biggest exponent. A sub 0 is the constant term because it doesn't have a variable. P of 0 is the y-intercept. So that constant will be your y-intercept. So back to this statement, your coefficients must be real numbers, and your whole number, your exponents, must be whole numbers. So no fraction exponents, no negative exponents, no decimal exponents. Your coefficients can be anything you want them to be as long as they are not imaginary. All right. So to look at a graph and know whether it is a polynomial, you are looking for a smooth, continuous function. So it can't have sharp points. It can't have breaks, it can't have holes, it's just got to be nice, pretty, smooth, continuous. Alright, so in behavior, and turning points is what this little chart has. Turning points is just if the degree is 4, then it can change directions 30 times. One less than the degree is how many turning points you can have. You're not necessarily going to have that many. And turning points are going to be maxes or mids, hills and valleys. What's really important is that you understand end behavior. What's the end of the graph going to look like? All right, so if your leading coefficient is positive, so looking here, the leading coefficient is positive. That means the right side points up. If your leading coefficient is negative, that means the right side points down. So your degree being even or odd is going to tell you whether the left side is the same or opposite. So if you're in even degree, your two sides point the same way. If you're in odd degree, they go in opposite directions. All right, so what I want from you is, can you look at a function and tell me the end behavior? So remember, make sure that it's in standard form, which means exponents are in descending order. And then we just look at the first term. Alright, so since it's a positive leading coefficient, we know that the right side goes up because it's an odd degree, odd exponent. We know that the left side goes opposite. So my picture looks like that. Now if I ask you to describe in behavior, I expect to see statements that look like this. As x approaches infinity, then f of x approaches what? As x approaches negative infinity, f of x approaches what? So a lot of times this will suffice for end behavior. But if I ask you to describe the end behavior, and that's the only question you're being asked, I'm going to want you to fill in these two statements. It's the exact same statement every time except for what is that end of the graph doing. So as we move to the right, what happens to the picture? It goes up, so towards positive infinity. As you move to the left, what happens to your picture? It goes down, so it's approaching negative infinity. All right, so number 2. Again, make sure it's in standard form, and then we're only concerned with the first term. The coefficient is negative, which means the right side's going to point down. Exponents or degree is even, which means that the left side's going to be the same thing as the right side. Alright, so to fill in our end behavior statements, as x approaches positive infinity, the function is going down. So it is approaching negative infinity. As x approaches negative infinity, so as we move to the left, the picture is approaching what? So as we move to the left, it's also going down. So it approaches negative infinity. All right, so zeros of a polynomial and multiplicity. So zeros are values of x, that should say for which, not whatever that says, for which f of x equals 0, also known as roots or solutions. Real roots will appear as x-intercepts. So zeros of a polynomial, if the degree is 5, it should have 5 zeros. But sometimes those zeros are going to repeat. Sometimes they're not going to be real, so you're not going to be able to plot them on the x-axis. They'll be imaginary. They'll get plotted on an imaginary axis, which we won't do. So to find zeros, you plug in, you set it equal to 0, sorry. To find zeros or x-intercepts, you set your function equal to 0 and solve for x. All right, multiplicity will make more sense when we work one, but basically it's the number of times the 0 happens. If it's an even multiplicity, you're going to touch the x-axis at that point and turn around. So what that means is if, for instance, you take an x minus 2 squared is one of your terms, one of your factors, then you get x equals 2. Well, technically that happened twice. So you're going to have an x-intercept at 2, but the graph is going to come to it and then back off. So if you're solving a little quadratic to get that 0, it's going to look quadratic at that 0. Odd multiplicity crosses the x-axis. Apparently I have lots of little typos I need to fix at that point. So if it's odd, it's going to go through the x-axis at that point, but if it's a 1, it goes straight through. If it's like a 3 or a 5, it's going to kind of wiggle through. So for an odd, if you have, like, let's say x minus 2 with like nothing there, and then you get a 0 at x equals 2. So that means at 2, your graph is going to go straight through that point. But if you had an x minus 2 to the third, then you still just get 2 for your 0, but you're going to wiggle through. So it's going to look, basically it's going to look cubic as it goes through that point. All right, again, by the time we get done with the lesson, that multiplicity stuff will make a little more sense. Okay, so they want us to find the zeros and describe the multiplicity. At this point, I'm not going to ask you to find zeros that you can't find by factoring. We will learn later in the week how to find zeros when you can't factor, but for now, we're only going to worry about things that factor. Okay, so if I take this function and I replace f of x with 0, then 4 obviously can't be 0. Using the zero product property, let me back up. We can say that each one of these factors equals 0, but 4 can't be 0. X minus 3 could be 0 when x is 3. And x plus 6 to the third could be 0. Take the cube root of both sides and you just get this. Solve and you get negative 6. Alright, so the 3, this was linear. So this has a multiplicity of 1. Which means if I were graphing it, I would go straight through 3. This one has a multiplicity of 3. So if I was, I don't know why I wrote out the whole word that time. Multiplicity, okay. If I were graphing it when I went through negative 6, I would kind of wiggle through that point. All right. So number 4, we're going to make it equal to 0. This one's not nice and factored for us. We got to do that part ourselves. So looking at what I have, I believe I can take out a GCF of 3x. So that leaves me x squared plus 4x plus 4. Alright, and then this factors to x plus 2, x plus 2. Alright, I can solve it from here, or I can write this as x plus 2 squared. That's a personal preference. So we get 3x equals 0. So x is 0, and that has a multiplicity of 1 because it only happened one time. X plus 2 happens twice. So negative 2 has a multiplicity of 2 because there are 2 of those x plus 2's in the problem. Alright, so intermediate value theorem is just a random thing that they plug in there, they put in this section. It's important in calculus. It can help you figure out how to graph things, which is the goal of this lesson is in the end, can we get a good graph of a polynomial? We're not really going to use the intermediate value theorem, like use it, it's common sense. So we're going to use some common sense and not actually quote the intermediate value theorem. But just make sure that you understand it. Intermediate value theorem says that if f of a and f of b have opposite signs, then there is at least one value between a and b where the function is 0. So if f of a, which is, let's say, this point, and f of b, let's say this point, have opposite signs. So this is obviously negative, and this is obviously positive. Then somewhere in here, we have to hit 0. Okay, so this is, let's say, f of 2 is negative 3, and f of 3 is 1.5. Alright, so what we're saying is that somewhere between 2 and 3, somewhere between here and here, the function is going to have to meet every value between negative 3 and 1.5, so it has to cross a 0 somewhere in there. Again, it's common sense, but they have a theorem for it. So, what you might be asked to do on your homework, or maybe even on your test, is to show that there has to be a 0 between the given integers. All you're going to do is plug in the numbers that you're given and show that the sign changes with the answers. Alright, so if we find f of 0, we're going to have 0 cubed minus 4 times 0 squared plus 2, which is 2. If we do f of 1, we're going to have 1 cubed minus 4 times 1 squared plus 2, which is 1 minus 4, so negative 3, plus 2 is negative 1. So all I need from you is a statement that say signs change 0 between. We'll make sure this actually says change because I don't know what I wrote. Okay, so everything you've learned so far today put together into one thing. And I need you to notice that I put this little blue line right here because I'm only going to do steps 1, 2, and 3. And then this is going to be things that I kind of think about in my brain, and I use my calculator to make a table to finish out my graph. Alright, so if I ask you to graph a polynomial, we are not just putting it in y equals and sketching a picture. You have to show me your leading coefficient test in behavior. You have to show me what the ends of the graph are going to look like. You have to find your x-intercepts. You have to, those next 3 statements are talking, those are part of number 2, sorry. So let me start over. Things that you have to do. You have to sketch your end behavior, you have to find x-intercepts, you have to find y-intercepts, and you need to think about your multiplicity at those x-intercepts. Once you have that, then you can make a table to fill in the gaps. I'm only going to do one example of this. If you need me to send you a video with another example, you're welcome to ask me for it, and I'll be happy to do it. Okay, so here we go. Things that must be done. You've got to describe an end behavior. So based off of this first term, it's positive and even degree. So those ends point up. Alright, to find x-intercepts, you are going to set it equal to 0. Again, I'm not going to give you something at this point that doesn't factor, you might have to do quadratic formula, but I honestly think everything's factored. Alright, so we get x squared equals 0. So x is 0, which has a multiplicity of 2. And you have this x minus 1 equals 0, so x equals 1, and that happened twice. So that also has a multiplicity of 2. Alright, and then we can find y-intercept. And to do that, you just plug in 0. Remember we said at the very beginning, I didn't put zeros in for these x's. We said at the very beginning that your y-intercept, is going to be whatever your constant is. Well, since this one doesn't have a constant, that means that the y-intercept is 0, as you can see. Alright, so to get a graph, we're going to come over here. We're going to put what we know. We know that we cross the x-axis here and here. We know that from this point we have to go up, because if we went up and came back down, we'd have another x-intercept. From here we have to go up, because the end behavior says both ends point up, and if we went up and came back down, we'd have more x-intercepts, so those have to be the last ones. Alright, because both of these have a multiplicity of 2, I know that I'm going to turn around right here and right here. So there's like some little hump going on right here. I just have to figure out where that happens. So all I really need to do for a table is figure out what happens at 0.5. So plug 0.5 in by hand, plug 0.5 in with your calculator. I suggest that you go to y equals on your calculator, type in the function, use the table feature to figure out the missing values that you need for your table, because sometimes it'll be more than just one. Alright, according to my calculator, if you plug in 0.5, you're going to get 0.0625. And the reason I suggest you do it with that table feature is you'll already have it typed into y equals, and you can graph and make sure that you're right. So this barely makes a little hump in the middle. Alright, so again, if you need more examples, if the problems aren't making sense when you're doing your assignment, let me know. When it comes to finding the points in the table, that's what people struggle with the most. You just got to look at what you have, and you've got to fill in all the gaps in between. So pick some numbers between all of your x-intercepts so you can fill in what's happening. I'm not looking for every possible number, because obviously you couldn't do every possible number. I don't need a lot of numbers. So like if you, for instance, had a picture where you know there's a 0 here and a 0 here, then I need to know what happens at 0 and what happens at 1. Okay? If that's not enough, you can put a couple of decimals in there, but usually that will be enough. Alright, as always, let me know if you have questions. Your assignment for today is right there. And I guess I'll talk to you tomorrow.